This is R.D. Sharma, Solution Class 12, Chapter 5, Algebra of Matrices. Very short answer question, VSAQ we are taking. If A is M by N matrix and B is N by P matrix, does A into B exist? If yes, write the order. A matrix, it is given M cross N, M row N column. B matrix N cross P, that is N row P column. So the column number of A is equal to the row number of B. So the column of first is equal to row of second, and that is why A into B is possible. And what is the order of the result? M into P. A cross B, the final result, the final order dimension will be M cross P. If A is this and B is this, write the orders of AB and BA. So A is, see, this is, how many rows are there? 2 rows. So A has 2 rows, 1, 2, 3, 3 columns, 2 cross 3. And what is B? There are 1, 2, 3 rows. And how many columns? There are 2 columns, 3 cross 2. Now A into B, A cross B, the column of first matrix should be equal to the row of the second matrix, and this is equal. Okay, what is the final result? 2 into 2. How about B cross A? B, the dimension is 3 cross 2, A, it is 2 cross 3. So because the column of the B is equal to the row of A, this BA is also possible. And what will be the result? Row and column, row of the first one and column of the second one, that is 3 cross 3. So this is the 2 cross 2 and 3 cross 3, AB and BA. This is the result. Because the order of A is 2 by 3 and the order of B is 3 cross 2. A is this, B is this, write AB. So you just have to multiply it. Just check the row and column. This is 2 cross 3, this is 2 cross 3. So this 2 cross 1, sorry, and this is possible. So 4, 3, 1, 2 multiplied by minus 4, 3. So this row with this column, 4 into minus 4 is minus 16 and plus 3 3s are 9. 1 into minus 4 and 3 2s are 6. So what do you get? This is going to be, see, 9 minus 16 is negative 7 and 6 minus 4 is 2. So negative 7 and 2 is the A into B. A is this, and we have to find out A transpose. And these are very short questions, so they'll just come in 1 or 2 marks. So 1, 2, 3 is A. Transpose is nothing but convert or change rows to column. Since this is a column matrix, you have to convert it into the row matrix, right? So A is this, AT will be only one row, 1, 2, 3. Now see here, this matrix, how many rows are there? 3 rows. How many columns are there? 1. The second one, how many rows are there? 1, column is 3. So the result will be 3 cross 3. Don't just think that we multiply this 1 with 1, 1 with 2, 1 with 3, then add them. Not like that. Okay. So even if we try to do this, you will see that the answer won't come as expected. It has to be 3 cross 3. So this kind of approach will not work. You just have to see that the result should come in 3 cross 3. So let me show you the exact what we are going to do. See, 1 into 1 will be 1. 1 into 2 will be 2. 1 into 3 will be 3. There is nothing for other additions. That is why. 2 into 1, 2 into 2, 4, and 2 into 3, 6. Now 3 into 1, 3. 3 into 2, 6, and 3 into 3, 9. This is the final result. Give an example of 2 non-zero 2 cross 2 matrices A and B such that A and B equals 0. Now if this type of question comes, whether it is 3 by 3 or 2 by 2, you just have to see, because in the multiplication you are multiplying the row of the first matrix with the corresponding column of the second matrix. So the multiplication of each element of the row with the column one by one should be 0. That is, if I am just take one column as values, another column as 0, in the second one take the first row or second row as 0, first row as 0 and second will with any number. Why we have done this? Because we know when we multiply this, the answer should come as 0, because every element when multiplied with the corresponding element, it should give you 0. Because we are essentially doing the row multiplication. These are the rows, these are the column. When we multiply one by one, it should come as 0. And that is what will happen here. 5 into 0, 0, 0 into 12, 0. So 0 plus 0, 0. 5 into 0, 0. 0 into minus 21 is 0, 0, 0. 9 into 0 is 0, 0 into 12 is 0. 9 into 0 is 0, 0 into minus 21 is 0. So 0, 0. So it's all about how you perceive and speculate how the multiplication will be done. Is this? Find A plus A transpose. So this is 2, 3, 5, 7. And we'll take the transpose, that is, we'll change the rows to column. So 2, 3 will become the column, first column, and 5, 7 will become the second column. So second one is the A transpose. 5, 7, just write it here, 5, 7. Now just add these two. 2 plus 2 is 4. 3 plus 5 are 8. 5 plus 3, 8. And 7 plus 7, 14. Right? So this is your final answer. Transpose is changing row to column and column to row like that. If A is this, write A square. A square is nothing but A dot A. Okay. Now, let me write I, 0, 0, I. Now, I here is corresponding to the complex conjugate or complex theory. Complex numbers actually. So, there I square is equal to negative 1. So, I into I is I square plus 0 plus 0. I into 0 is 0. 0 into I is 0. So, this will be 0 plus 0. Then we have 0 into I as 0 and I into 0 is 0. 0 plus 0. Now 0 into 0 is 0. I into I is I squared. So what do you see here? This is 0. This one is 0. This is I square is minus 1. This is also negative 1. So just replace it. Minus 1, 0, 0, minus 1. This is your A square. This is why your reference. If A is this matrix, find X. Satisfying X should be between 0 and 90 degree, 0 and pi by 2. When A plus A transpose is equal to I, identity matrix. So I is identity matrix. So let us add it. A matrix, cos x, sin x, minus sin x, cos x. Now add the transpose one. Transpose matrix, A transpose. So this will be A transpose is cos x and sin x will become the column. Cos x, sin x. This will be column minus sin x and cos x. Okay. So this is equal to the identity matrix. Identity matrix is 1, 1, this 0, 0. Now just add this. Cos x and cos x is 2 cos x. Sin x minus sin x is 0. Minus sin x and sin x is 0. And cos x is 2 cos x. And this is equal to 1, 0, 0, 1. So basically 2 cos x is equal to 1. If you equate both of these 2 cos x. Cos x is half. So what is the value between 0 and 90 degree for which, or 0 and pi by 2, which is going to give you the half value, which is 60 degree. 60 degree, cos 60 is 1 by 2. So you can either write just 60 degree as 60 degree only, or since the question is given in the terms of pi, so just write the answer as pi by 3. Okay, pi by 3. Now the same thing is here. Now we have to take the A into A transpose. So let us do it. Cos x minus sin x, cos x. And take the transpose. What is the transpose? The rows will become column. So this row will become column. Cos x will come here, minus sin x will go down. And then sin x, cos x, same thing. Sin x here and cos x here. Now multiply them. So first row with first row of the first metric with the second metric, first column. Cos x and cos x is cos squared x. Minus sin x and minus sin x is minus sin square x. Minus minus plus, so cos square x plus sin square x. Now first row with the second column, cos x sin x is cos x sin x. And then we have minus sin x cos x. Minus sin x cos x. Now second row with the first column, sin x cos x. Cos x and sin x is minus sin x cos x. Now second row with the second column, sin x sin square x. Cos x is cos square x. Okay, so this cos x minus sin x is going to be 0 because they both are same term. This also becomes 0. Cos square x plus sin square x is 1. This is going to be 1. This is going to be 1. So just write it like this. 1, 0, 0, 1. And this is nothing but the identity matrix. This is I2, identity matrix. So this is how it is going to be done. If I is this I is equal to this left hand side and I is 2 by 2 unit matrix, find x and y. So I am doing it directly. Okay, 1, 0, 5, y and 5. Then multiply 2 inside. Just multiply this and then we'll add 2 in. Multiply every term by 2. 2x, 2 0 0, 2 1 2, 2 2 4 minus 4. And this is equal to identity matrix. Identity matrix is what? 2 by 2 with the diagonal as 1. All the diagonal will be 1. Okay. Now add these two. 1 plus 2x is 2x plus 1, 0. Y plus 2 is 2 plus y. 5 minus 4 is 1. So this equates to the identity matrix. 1, 0, 0, 1. Now you can just equate the value, that is from the first one, corresponding value we have to equate, right? So this 2x plus 1 is equal to 1. 2x plus 1 is equal to 1. And 2 plus y will be equal to 0. From here you get y equals minus 2. From here you get 2x equals 1 minus 1, 0. X equals 0. X will be equal to 0. So this is x and y value. But you have to do like this. On the left I have showed already. If A is this, satisfies the matrix equation A square equals K into A. Write the value of K. Now A is this. So there is, we have to actually find out A squared. And then equate it to all terms multiplied by K. So how to do this? A square. A is this. 1, negative 1, negative 1, 1. Again I am writing A again. 1 minus 1, minus 1, 1. So 1 into 1 is 1. And minus 1 into minus 1 is 1. So 1 plus 1. Now first row with second column. 1 into minus 1 is minus 1. Minus 1 minus 1 is minus 1. Minus 1, 1 is minus 1. 1 minus 1 is minus 1. Minus 1 minus 1 is 1. 1 1 is 1. Okay. So what do you get? You get everywhere 2 with the same signs as in the A. So this is equal to K into A. Now this multiply every element of A with K. So what do you get? Wherever 1 is there, just replace it by K. So K minus K plus K. So whichever you equate, it will come down to K is equal to 2 only. So K both ways, K equals 2. This is how you have to actually do it. Right? Step by step. Write all these things. A is this, A raised 4 is lambda A. Then write the value of lambda. So you just have to multiply it. A is there. Now first we'll find out A square. Then we'll find out the square of A square, A4. So this is A. This is also A. Now multiply. 1 1 is 1. 1 1 is 1. 1 plus 1 is 2. Now same here. 1 into 1 is 1. 1 into 1 is 1. 1 plus 1. Then this row, this column, 1 into 1 is 1. 1 is 1. 1, 1, 1, 1. In same, discussion, logic. This will be 2, 2, 2, 2. So 1 square is 2. Now 2 square will be, it will be 2 cube actually. When you multiply this a square with a square, the term will be cubed. So 2 into 2 is 4. 2 into 2 is 4. So every element will be 4 because there is no change. Everywhere it is 2. So I'm not writing anything. I'm just, I know that it is going to come as 8, 8, 8, 8. Whichever you do, whichever row, column, because the elements are same everywhere. So this is equal to lambda into a. So just equate this lambda, 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 and that is going to give you lambda is 8. Even if you equate with anyone, lambda is going to be 8. A is this, a square we have to find out. And a to the power 4 also there is a question coming. So just see it very carefully. Minus 1, 0, 0 and 0, negative 1, 0, 0, 0, minus 1. Okay. Now all the diagonal element are negative 1. Same here. All the diagonal element are negative 1, others are 0, and we'll properly multiply the matrix. So negative 1, all others, see, negative 1 will become 1. Others all are zeros, 0 into 0, 0 into 0. First row, second column, again, only 0 will come. First row, second column, all elements are 0 if you multiply. It is very clear from this that wherever minus 1 will multiply, there will be 1, and that is only possible in the when I and j are equal. So all others will be 0, only 1 will be in the diagonal, right? So this is your a square. This is your identity matrix. 1, 0 is remaining, okay? Just put it there. Same thing you have to do for AQ. So a square we have already done just now in the previous question. So let me write the a square which we have already done, and now we will multiply it by a. So a was actually identity matrix. A square, sorry. This was the identity matrix. Now we will multiply it by this all diagonal element with negative 1. So 0, minus 1, 0, 0, 0, 0, minus 1. Now when you multiply, you will by yourself know what will happen. 1 into minus 1 is minus 1. Other all are 0. 0, 0, 0, 0. Okay. When you do this column, this row, all are zeros. This is also 1 into 0, 0, 0 into 0, 0, 0 into minus 1, 0. So again 0 will come. So by the analogy I know, you have to do it, entirely. I'm just saying that negative 1 will come in the diagonals. So this is the final answer. AQ. You have to do it like this. Okay, on the left, the way it is being given. You have to write exactly like this. A4. Okay. So I'll show it to you here because we have done a question like this. So a square will be 9009. When you multiply it, it will be 810081. See, this is a simple multiplication, nothing else. And sometimes when you have practice, you can easily find out without even multiplying that what is going to come. X and 2 and 3 and 4 equals 2. So let us multiply this. X and 2, and this is 3 and 4. So this is equal to 2. 3x plus 4 to the 8. So this is 1 row, 2 column. This is 2 row, 1 column. 1. So the result will be 1 by 1. That is only 1 row, 1 column will be there. One value. So this is equal to 3x plus 4. 3x plus 8 equal to. So 3x will be 2 minus 8. That is going to be negative 6. And negative 6 by 3 is negative 2. So x will be equal to minus 2. Okay, this is your answer. Next one is, if A is equal to Aij is a 2 by 2 matrix such that Aij is I plus 2j, write A. So let me write a proper matrix first, 2 by 2. This is A, this is 1 row, first row, second column, this is first column, second column. So row number and column number, wherever it is intersecting, just write it. A11, A12, A21 and A22. Remember, I is the row number, J is the column number. So the internal element of the resultant will be I plus 2j. So Aij, this is. I am writing the first number, 1 plus 2 into 1. Here 1 plus 2 into 2. Here we have 2 plus 2 into 1 and 2 plus 2 into 2. Okay. So what do you get? See, 1 plus 2 is 3. It is not 2, it is 3. 2 2s are 4, 4 plus 1 is 5. 2 plus 2 is 4. 2 plus 2 is 4 and 2 2s are 4, 4 plus 2 is 6. So the answer is 3, 5, 4, 6. 3, 5, 4, 6. So this kind of questions, there are more questions coming like this. Write matrix A satisfying A plus this matrix equals this matrix. So just take this 2, 3, 1, minus 1, 4 on the right hand side and subtract it. So I am subtracting it here only. So I am writing these two matrices and I will write the answer of the subtraction just now. 3 minus 2 is 1, minus 6 minus 3 is minus 9, minus 3 minus 1 minus 1, 1 minus 3 is minus 2, it will be negative 2. Because minus 3 plus 1 is negative 2, 8 minus 4 is 4. This is your final result. Okay. Directly we have done, you have to do it like this, okay. If A is a square matrix such that Aij is I squared minus j squared, then write whether A is symmetric or skew symmetric. So this is a square matrix. It can be 1 by 1, 2 by 2, 3 by 3, n by n. So it is not given in this question. So we can assume, let us assume that it is 2 by 2. We are just assuming it. Okay. And then we'll prove. So if we make a 2 by 2 matrix, this is first row, second row, this is first column, second column. So how do we write A11, A12? That is A21 and A22. First one is row, second one is column, the subscript. So Aij it is. So I is the row number, j is the column number. So these are the row numbers and these are the column numbers. So what do? We will just put I and j, 1 and 1 here, 1 square minus 1 square. In place of I and j, we'll place 1 and 2, 1 square minus 2 square. 2 and 1, 2 square minus 1 square. 2 square minus 2 square, I and j. So what do we get here? 1 square minus 1 square is 0. This 2 square minus 2 square will also be 0. 1 square minus 2 square will be 1 minus 4. That is negative 3. 2 square minus 4, that is 4 minus 1 is 3. Okay, this is A. Now, when we take the transpose of this matrix, because if A is A transpose, it is symmetric. A transpose is negative A, that is skew symmetric. So we have to verify this. So A transpose will be what? I am changing it to row and column. So 0, negative 3 is 0, 3, 0. So we have transposed it. If I take negative outside, it will be 0, minus 3 and 0. So this is A transpose is negative of A, which signifies that this is a skew symmetric matrix. A is skew symmetric. For any square matrix, write whether A into A transpose is symmetric or skew symmetric. So we have just seen, now we will use this AAT. That is, this A into A transpose is that matrix which has to be told whether it is symmetric or skew symmetric. Okay. So A into A transpose. So what is the possibility? The possibility is that when we take the transpose of this whole, if we take say A and B transpose, it always will be, it will be A transpose, B transpose, but B transpose will come first. That is, AB transpose is nothing but B transpose into A transpose. Okay, transpose is nothing but changing rows into column. Okay, so we'll take the transpose of the second one and then A transpose. So what is the transpose of a transpose? When we change row to column, column out to row, it will be same. So transpose of a transpose will be the original matrix. So A transpose is nothing but the original matrix, which is going to be A only. And this is A transpose. So when we take this A transpose, when we took the transpose, the same matrix came. That is symmetric matrix. If Aij is a skew symmetric matrix, then write the value of sigma Aii. First, we are being told that this is skew symmetric. So let us assume that we have a matrix. Say A is our matrix. What is that matrix? It has 2 rows and 2 columns. Just assume that. A11, A12, A21, A22. Okay. Now when we take the transpose, what does it mean? Transpose means row to column, column to row. So this row will become column. So A11, A12, this will be the first column, and the second row will be second column. So A21, A22. That is, wherever A12 was there, A21 came. Wherever A12 was there, A21 came, and wherever A21 was there, A12 came. So Ij was replaced by Aj. So wherever Aij was there, Aj has come, right? And since it is skew symmetric, that is, when we take the transpose of A, negative A will come. So Aij and Aj are replacing place, but they are negative. So Aij, because the transpose is negative, so since the places are replaced, the places are replaced by the negative element. Okay. That is, when I am changing the position with row and column, I will become J, J will become I. So Aij is going to become Aji. But thing is, it is negative, it is skew symmetric. It is Aij and Aji. I just have to change that. So when I is and J are equal, that is A11, A1, A22. So it is Aii. So let us replace Ij by J by I. So Aii on the both sides. It will be negative. So now take this negative on the left hand side. So Aii plus Aii is going to be 0. This is 2 Aii is equal to 0. That is nothing but Aii equals 0. Now when Aii is 0, you take sigma of any Aii, A11, A22, A33. They are all zeros. So sigma, this A11, A22, A33. So all these are zeros. When you add this, you will get a 0. Okay. Sigma Aii equals 0. If Aij is a skew symmetric matrix, then write the value of Aij, sigma Ij. So I just told you about skew symmetric matrix. So assume that a matrix A is there. When we take the transpose, Aij will become Aji. Ij will become Ji because simply row and column we are changing. If Aij is there, minus Aji will come because it is a skew symmetric matrix and the question it is given. So if you replace it by Ii, what will happen? It will be simply J replaced by J by I. So Aii equals negative of Aii or Ajj equals minus Ajj. Right? So I just told you about the matrix. So if you replace it, it will be, if we take on the left hand side, twice of Aii equals 0. So Ai will be equal to 0. So this is what we got. Now when we add it, it will be the addition of all the elements of the matrix. Okay. So when we take the sigma Ij of Aij, I can be any number, J can be any number. So we cannot fix it, but we can generalize it. For example, this is A11, A12, A21, A22. So this sigma is nothing but A11 plus A12 plus A21 plus A22. This is what we are adding. This is just 2 by 2. It can be n by n matrix, whichever. So A11, A12, like this it goes. Then this is A11 till A1n. And we have A11 to AN1. That is A11, A1 will be there, A11 will be there, A21 will be there, A12 will be there, A13 will be there, A31 will be there. So we'll not stop, we'll just give the ellipses dot. But you see that all these Aii are equal to 0. We just saw in the previous question and this question also. So all these A11, A22, A33 are zeros. And also every element Aij is negative of Aji. That is A12 is negative of A21, A13 is negative of A31. So they will cancel out. Nothing will remain. All these are going to be either zeros or they are going to cancel out. So final result will be nothing but 0. I hope you got the idea. A13, A31 are negative of each other. So finally 0 will come. If A and B are symmetric matrices, then write the condition for which A into B is also symmetric. So the whole matrix is given AB, but also given A is symmetric. A is symmetric, that is A transpose will come as A. B is also symmetric, so B transpose will come as B. Okay. Now write the condition for which AB is also symmetric. AB will be symmetric when AB transpose is going to be AB. Same thing will come. Okay. So I just told you, when we take the transpose of two values, it will be B transpose into A transpose. You can write this as B transpose dot A transpose. Okay. B transpose A transpose. B transpose is already given as B. A transpose is already given as A. So BA is equal to AB. Please remember, when you multiply a matrix, A dot B, B dot A, they are not equal. But the case here is, in order to be this to be symmetric, AB to be symmetric, BA has to be equal to AB. If B is a skew symmetric matrix, write whether the matrix A transpose is symmetric or skew symmetric. So we have to take A transpose as a single matrix. That is, we have to prove whether this ABAT is symmetric or skew symmetric. So this A transpose, if it is symmetric, if you take the transpose of this, it should come the same matrix. Okay, I just have to put a transpose there. If this matrix ABAT transpose, if you take the transpose, if it comes as negative of itself, ABAT, so we will say it is a skew symmetric. So as I said, we are taking transpose. So let us take the transpose now and see what is going to come and what we can utilize. So A, B and A transpose we are taking. Now, I told you already AB transpose was what? B transpose, A transpose. If we introduce C also here, it will be C transpose, B transpose, A transpose. So first this transpose, A transpose, then B transpose, then A transpose. Okay. So this transpose of a transpose is the original matrix. If you take the transpose of a transpose, row to column and column to row, again same matrix will come, so A will come. This is A. This B transpose is given in the question as skew symmetric. So skew symmetric means B transpose is going to be a negative of B. Just write negative of B. And this is going to be A transpose. This remains same. So what do you get? When you took the transpose of this, you got a negative of that thing, which is implication that this is a skew symmetric. Same question we are doing, but here B is a symmetric matrix. Same thing we are doing, okay? We'll do the same thing. Because here I said if it is this B transpose was negative B, then only it was skew symmetric. But when B transpose is going to be positive, the positive will come. So first condition would have been true. So this would have been symmetric. So I hope you'll be able to do, right? If A is a skew symmetric and n belongs to capital N such that A raise n to the power t is equal to lambda A raise n, write the value of lambda. So we'll take one by one. Step by step we'll take. First thing is given as A is a skew symmetric. Skew symmetric means if you take the transpose of A, it is going to be negative A. First thing. Now coming to this one, A raise n to the power to transpose. So t is not the power, t is just a transpose. So if you take the power of A and then transpose, or if you take the transpose and then take the power, it doesn't matter. It doesn't matter. So you are just changing to row and column and then applying the power. So it doesn't matter when you do the transpose first or later. So you will just take the A transpose and then take the power. So this A transpose is what? This is already given as negative A. This is given as negative A because it is a skew symmetric matrix. So negative A raise n, and this is given in the question as lambda A to the power n. Minus A raise n can be written as minus 1 to the power n and A raise n. Because minus 3 raised 10, for example, can be written as minus 1 raised 10 and 3 raised 10. So minus 1 raised n and a raised n. This is equal to what? Lambda a raised to power n. So this gets cancelled. Lambda will be equal to minus 1 to the power n. This is the value of lambda. If A is a symmetric matrix and n belongs to capital N, write whether A raised n is symmetric or skew symmetric or neither of these two. So this question and next question are same, almost same. Just very carefully listen to me what I am saying. A transpose is equal to A because it is symmetric matrix, it is given. Now we have to find whether A raised n is symmetric or non-symmetric. So A raised n to the power t. It is not power t, it is only transpose. So it is equal to an if it is symmetric. I am just saying, if you take the transpose and it comes negative a raised n, then it is skew symmetric. These two are very important. Now let us come back to the question. Only a raised t equals a is given. So the step is like this. We will take the transpose. So as I told you, if you take the power and then do the transpose, or if you do the transpose and then take the power, it doesn't matter. So you can write a raised n t, this one. So a raised n transpose can be written as a transpose to the power n. Okay, t is not the power. So a raised t to the power n, and this is at is given what? It is a. So you can replace it by a raised n. So as I said, when you took the transpose and the final result is a raised n, there are two options which I gave. It is symmetric because it is just positive power. Same thing here. In this question also, we are doing the same question, but 28 or 29 are very important because here specifically even natural number is given. Okay. So even natural number, next question will have odd number. So what is the criteria? See here. Because 27th question we have to reapply, but here we have to put the negative sign and positive sign. How does it work? A is a skew symmetric matrix. That means A transpose is going to be negative A. This is skew symmetric, first condition. And is an even natural number that we'll use later. Whether A raised n is symmetric or skew symmetric or neither of these two. So A raised n, if we take the transpose and if it comes as A raised n, that is, this is going to be the symmetric. A raised n transpose, if it is going to be negative of A raised n, that is going to be skew symmetric, right? So let us start the steps now. So we have to take the transpose, A raised n transpose. So you can replace t by n because, if you do the transpose and then raise n or raise n and take the transpose, it doesn't matter. So this is going to be what? A transpose and raise n. Since A raised t is already given as negative A, so you can write it as negative a raised to n. How can you write this? This is negative 1 of n and a raised n. See, now minus 1 to the power n is even natural number. Minus 1 to the power 2, 4, 8 like this, 16. This always will be positive. Minus 1 to the power 2 is what? It is plus 1. This will always be a raised n. That is only possible when this is symmetric matrix. When it is odd natural number, it is going to be a skew symmetric because always negative 1 will come. Okay. Same thing in this question as I just told you. This is given as odd natural number. So I told you that if this n comes even, it will be even. That is, it will be a symmetric matrix. But if n is odd, it will give us negative number. So it will be skew symmetric. Same thing you have to do. Right? Same thing. But only thing is minus 1 raised n. N is, because it is odd, it is always be negative and it is a skew symmetric matrix. Okay, this question we'll take in the next discussion. Thank you so much. Take care of yourself. If A and B are symmetric matrices of the same order, write whether AB minus BA is symmetric or skew symmetric or neither of the two. So A and B are given as symmetric matrices. That means if you take the transpose, the same metric is going to come back. B also is symmetric, so B transpose is going to be B. write whether AB minus BA. So AB minus BA, when we take the transpose of this, if the transpose comes to be negative of AB minus BA, then we'll say that this is skew symmetric. This is skew symmetric. But when we take the transpose of AB minus BA, and when the transpose is going to come as AB minus BA itself, then we call it as a symmetric matrix. So when I'll prove it, one of these will come. So keep an eye on it. So we'll take the transpose of this. Please remember, whenever we take X minus Y transpose, this is equivalent to X transpose minus Y transpose. So AB minus BA transpose is AB transpose minus BA transpose. Now, one more thing. If XY transpose we write, it will be Y transpose X transpose. This will come first. This will be B transpose A transpose minus A transpose B transpose. Okay. Now, what all is given? See, B transpose A transpose already is given because A and B are symmetric matrices. So A transpose will write as A, B transpose will write as B. So in place of A transpose A, in place of B transpose B. So BA minus AB. Now when we took the transpose of AB minus BA, what should come? Either AB minus B or AB minus BA in negative. But it is not coming AB minus BA. So what it will be? If we take negative outside from here, that will be AB minus BA. And what does it mean? This is the first one, which is skew symmetric because it is negative of the original content. Write a square metric which is both symmetric as well as skew symmetric. The best one is null matrix. Null matrix is always symmetric and skew symmetric also because it is nothing. So see, A matrix is null matrix, so we are assuming it to be symmetric and skew symmetric because when you take the transpose of the null matrix will come back. So AT will be equal to A. So if you take the negative of A, that is minus 1 of this null matrix, negative of A, what will this be? If you take the transpose of this, even if you take minus inside, it doesn't matter. It will again be A, this minus A only. That is both sides multiplied by minus A. So transpose will be minus A. So that is both symmetric and skew symmetric because both the time it is coming as symmetric matrix also and skew symmetric because just multiply minus A and on the right hand side minus of 0, 0, 0, 0. Find the value of X and Y if this. So we have done a question like this. Questions are coming like this. So I'll just do it here only. So just multiply 2 here. So now I'm adding 2 plus Y is 2. 2 plus Y, then 6 plus 0, 2x plus 2 will be there. So 2x plus 2 will be 8. 2 plus Y is 5. Y will give you 5 minus 2, 3. And this is going to be 2x is 6. So x will be 6 by 2, that is 3. So 2x is 6. So you get 3. So y is 3 and x is also the number which I showed you. Now this type of question also we have done. Since it is CBSE, we'll do it. X plus 3 is equal to 5. So x plus 3 is 5. And 4 is 4. Y minus 4 is 3. From first you get x equals 5 minus 3, that is x is 2. 5 minus 3 is 2. And y is 3 plus 4, so y is 7. So this is how you get x and y. You can just, what I intend is, this is the way you have to write, okay? You have to write in the same way which is given on the left hand side, which I showed you in the printed content. Find the value of x for the following. 2x minus y equals 6. And y is already given as negative 2. So y is negative 2. Just put in here. And all others, 3 is 3, 5 is 5. So y is minus 2, put in here. There is plus 2 equals 6. 2x will be 6 minus 2. That is going to be x equals 2. So y is negative 2. x is 2 here. Find the value of y if this. So x is already given 3 here. If you just equate the corresponding elements of the matrix, x is 3 and x minus y is equal to 2. Just put 3 here, 3 minus y equals 2, y will be equal to 3 minus 2, that is going to be 1. So x is 3, y is 1. This is how you do it. This is how you have to write, right? One by one, step by step. This also will do. 3, this minus y is already y. Minus y is already given as 2. So y is equal to negative of 2. Now put in any of the equation. So 3x plus y equals 1. Y is negative 2, so 3x minus 2 equals 1. 3x will be equal to 1 plus 2, that is 3x is equal to 1. So y is negative 2, x is 1 here, like this. If matrix A is this, write A transpose. So this is 1, 2, 3, this is our A matrix. And A transpose is what? Row will be column, so 1, 2, 3. So what do you get? See, this is 1 cross 3, 1 row and 3 columns. And this is 3 row, 1 column. So result will be 1 cross 1, that is only one content will be there. 1 row, 1 matrix. So 1 into 1, 2 into 2 is 4, 3 into 3 is 9. So this becomes 9 plus 1, 4, 14. 14 will be the answer. This is how you have to do it, okay? One by one step. Okay, we have to find x. See, 3y is equal to 0. So y is equal to 0. 2x plus y equals 6. Since y is 0, 2x equals 6. Divide both sides by 2. You get x equals 3. So y is 0 and x is 3. So this is how you have to write also. A is this. A plus A transpose. So this is 1, 2, 3, 4. Now we'll make the rows as column. 1, 2 will be the column. 3, 4 will again be the column. And then we just add them. 1 plus 1 is 2. 2 plus 3 is 5. 3 plus 2 is 5. 4 plus 4 is 8. Okay. So this is CBSE 2010. And this kind of question comes in 1 or 2 marks. Not more than that. Okay. So since b is already given 2 here, just put b equals 2. A plus b equals 6. When you have a plus b equals 6, b is 2. So a plus 2 equals 6. A will be equal to 6 minus 2. 4. A is 4. This is a equals 4. If A is a matrix of order 3 by 4 and B is a matrix of order 4 by 3, find the order of the matrix AB. Okay. A is 3 by 4. B matrix is 4 by 3. See, this is when you multiply, the column of the first matrix has to be equal to the row of the second matrix. Okay. But the result will be the row of the first matrix and the column of the second matrix. So 3 cross 3. So the order of the matrix of AB will be 3 by 3. If this is an identity matrix, then write the value of alpha. Okay. Identity matrix I2 is diagonal will be 1, 1. So this is I2. So you have cos alpha minus sin alpha and cos alpha. So this is identity matrix. So 1, 1, 1, 0, 1, 0, 0, 1. So cos alpha equals 1 and sin alpha equals 0. So this will be cos 0 is 1 and sin 0 is sin 90. When sin will be 0? Because cos 0 is 1. So what we are going to do, because there are other combinations also. Sin 0 is 0 and cos 0 is 1. So this angle will be 0. So alpha equals 0. Because sin 0, cos 90 is 0 and sin 90, if you take the value, this sin 0 is of course 0 and sin 90 is 1. Okay. So you have to find out the value of k. So just multiply them. So let us multiply. 1, 2, 3, 4. This is going to be 3, 1, 2, 5. So multiply 1 with 3. 3 ones are 3. 2 twos are 4. Then 1 into 1 and 5 twos are 10. 3 into 3, 9 and 4 twos are 8. 3 ones are 3 and 5 4s are 20. So 7, 11, 17 and 23. So this is equal to 7, 11, K, 23. So all others are same, only K we have to find out. That has to be 17 in order to this to be equal. So K is 17 here. If I is the identity matrix and A is a square matrix such that A squared equals A, then what is the value of this expression? Okay, so we will expand this expression, we'll use certain properties and then we'll try to find out the value. So I'll do one by one step. Okay, see, I plus A, this is whole squared minus 3A. So I plus A whole square is what? We cannot do A square plus B square plus 2AB. This is matrix. So we cannot do that. We have to do step by step. So this I into I is I square. I square will be equal to 1. I square is always 1. Identity square is 1 only. Then I into A and A into I. I into N, A into I. Whenever we multiply a matrix by I, it is going to be A. Same matrix. And then A square. So this IA and AI will be equal to A. I is already equal to A. I am writing I. It is not true. It has to be A. I'll just change it. So this is, see, I'm just changing it. A. And A squared is already given in the question. A square is A. A square is A. So what do you get? I plus A plus A. A square is A. So what do you get? I plus 3A. Now I plus A whole square is I plus 3A. Then we have this minus 3A also. So 3A gets cancelled, you get I. This is your answer. This is the way you have to write, okay, one by one. You have to write I square equal I. You have to write A into I, or A into I is going to be A. Distributive property, etc. If A is this, is written as B plus C, where B is a symmetric matrix and C is a skew symmetric matrix, then find B. So since this B and C, how we are going to write, we have already seen in the other exercises, but I'll tell you, B will be half A plus A transpose, C will be half A minus A transpose. Because when you add this half A plus A transpose and half A minus A transpose, this is going to give you A only. So this 1, 2, 0, 3 is A. A transpose is what? Row will be column. 1, 2 will be the first column, 0, 3 will be the second column. Now just add them. 1 plus 1 is 2, 2 plus 0 is 2, 0 plus 2 is 2 and 3 is 6. So this is, now take the half, 1, 1, 1 and 3. It is not 6, it is 3. So this is going to be B. Now let us find out C now. C is half A minus A transpose. So 1, 2, 0, 3. This is your A and minus A transpose. A transpose is what? 1, 0, 2, 3. So 1 minus 1 is 0, 2 minus 0 is 2, 0 minus 2 is minus 2 and 3 minus 3 is 0. And you have a half also. So divide everything inside by 2, that is multiply by half. 0, 1, negative 1, 0. This is going to be C. So you have a B and you have a C also. So B is a symmetric matrix. So you have to show also that it is a symmetric matrix. That is, I am transposing it. So when you take the transpose, it is going to come same. Row to column, column to row. And this is C. So I am taking the transpose. So 3 transpose we are taking. 0, 1 will be the column and minus 1, 0 will be the column. Now take the negative outside. It will be 0, 1, negative 1, 0. And this is nothing but C. So C transpose is negative of C. So what do you get? This B is symmetric and C is skew symmetric. Now you have to add B and C also and show that it comes to the original matrix A. So this 1 and 1, 2, this is going to be 2, 1 and 1 minus 1, 0, and then 3 plus 0 is 3. So this is A. This is your original matrix. If A is 2 by 3 matrix, B is a matrix such that A transpose B and B A transpose both are defined, then what is the order of B? See, A is 2 by 3, B is not given. Let us assume it is row into column or M into N. But A transpose B is defined and B A transpose is also defined. So A transpose A transpose will be 3 by 2. If you take A transpose, it will be 3 by 2. And since A transpose B is defined, so if you take row and column, has to be equal to 2. So we got the row of B, row into column. Now BA transpose is also defined. B is 2 into C, C assumed to be column, and A transpose is 3 by 2. So since BA transpose is also defined, C has to be 3. So C is 3, row is 2, column is 3. So the order is 2 by 3. But you have to do in this way, which is being given here. One by one step you have to take. What is the total number of 2 by 2 matrices with each entry 0 or 1? Now this is a 2 by 2 matrix. 2 by 2, there are 4 elements. The element can be either 0 or 1. So it can be 0 or 1. So how many elements are there? 4. Every element can be either 0 or 1. So 4 square, it is going to be 16. Okay, I hope you got the idea. 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1 like this. There will be 16 combination. Now if it is this given, let us equate, because x is already given as 3. You can take x minus y equals 1. x3 here at 3 minus y equals 1. Y will be equal to 3 minus 1, that is going to be 2. So x is 3, y equals 2. If a matrix has 5 elements, write all possible orders it can have. See, every matrix will be the multiplication of row and column, m into n. So can you tell me which are the two numbers which when multiplied gives you 5 integers? Okay, positive integers. It can be only 5 into 1 or 1 into 5. That is, any matrix A will be m cross n. And then m cross n has to give you 5 elements. So these are 5 elements. It can be 5 elements like this. So it can be only 1 row 5 columns or 5 row 1 columns. There is no other possibility. Because if I ask you m into n is 5, you can only tell me m can be 5, n can be 1 and vice versa. Okay? So there are only two possibilities. For a 2 by 2 matrix Aij whose elements are given by Aij equals I by j, write the value of A12. So this is 2 by 2. So first row, second column, first row, second column. This is A11, A12, A21, and A21 and A22. Okay. Now we don't have to worry about others. We just have to find A12. A12 is what? I is 1, j is 2. So it will be 1 by 2 because it is I by j. 1 by 2. You are getting directly here from A1 to I because I is 1 and j is 2. Now find the value of x. So what do you get? 2x and you 3x, multiplying x inside. Now multiplying y inside, negative y and y. This is 10 by 5. Let me add bit for 2x minus y and 3x plus y, and this is equal to 10 by 5. So now just equate. 2x minus y equals 10 and 3x plus y equals 5. Now just add 5x equals 10 plus 5 is 15, x will be equal to 5 3 is 15, 3. X is 3. Now put in any of the equation. I am putting in 3x plus y. So 3 into 3 plus y equals 5, 3 is 9, 5 minus 9 is minus 4. So x is 3 and y is negative 4. Okay, if this, just take this one on the left hand side. So you just have to subtract these two. So 9, I am subtracting 9, 1, minus 1, 4 with 1 to 1. So 9 minus 1 is 8, minus 1 minus 2 is minus 3, 4 minus of minus 1 is 5, minus 2 minus 0 is minus 2, 1 minus 4 is minus 3, 3 minus 3, 9 is minus 6. This is your final answer. But you have to write all these like this, okay? Okay, you just have to find the value of b here. Please remember. So don't worry about c and d. A minus b is negative 1 and 2a minus b is equal to 0. Now subtract these two. So when you subtract, 2a minus a is going to be 1. 2a, that is a is equal to 1. Simply a is equal to 1. B gets cancelled. Now just put this a in any of this equation because we have to find b. A minus b equals negative 1. A is 1. So 1 minus b equal to negative 1. B is equals 1 plus 1. That is going to be 2. So b is 2. C and d is also there, but you don't have to find c and d. Just b. So b is 2. For what value of x is the matrix this? A skew symmetric matrix. Skew symmetric means A transpose has to be equal to minus of A. I have to put a negative here. 0, 1, negative 2, minus 1, 0, 3, x, negative 3, 0. And this has to be equal to negative of A. I hope you got the idea. Skew symmetric has to be negative. So let me put a negative here. It is skew symmetric, negative here. Okay. Now let us take the transpose. Row will become column. 0, 1, 0, 1 minus 2 will be first column. Negative 1, 0, 3 will be the second column. And x minus 3, 0 will be the third column. Now we'll just change the sign because negative, it has to be multiplied by negative. So just change the sign. So the minus x is minus 2 and x is 2. From two equalities. So in both the cases, x is going to be 2. From here, x equals 2. But you have to write like this, okay? This one. If matrix A is this and A square equals PA, then write the value of P. 2 minus 2 minus 2, 2. We'll multiply this. But I would like you to try another method. This is for you. If A square minus this, it can be written as A square minus PA equals 0. And if you take A common, it will be A minus P. So is this possible? Because that will be A equals P. And A is actually 2 minus 2 minus 2, 2. And P will come as 4. You'll just see. So how it doesn't work? If you take this equation, why it doesn't work, that has to be actually answered by you. I need the explanation, okay? If any one of you can give. But let us continue with our solution. 2 minus 2 minus 2 and 2. So we have to multiply it properly. 2 into 2, 4. Negative 2, 4 again. 4 plus 4. 2 into, now first row and second column. 2 into minus 2 is minus 4. And 2 into minus 2 is minus 4. Minus 2 to minus 4, 2 to 4. Minus plus and 2 to 4. So this is going to be 8, negative 8, 8. I'm just saying, I'm writing 8 but it is negative also. So the multiplication is simply 4 into something. 4 into 2, that will be 8. So P is 4. Okay. So it is negative 8 and negative 8. I have not written it. So I just want you to give me explanation why this A, if it equates to P, A is 2 minus 2 minus 2, 2, but P is becoming 4. Why? Okay, this is all about this exercise. Thank you so much. Take care of yourself.